Algebra 1, Chapter 5, Section 4, Solving Compound Inequalities. So, a compound inequality, compound means like to put together, we're going to look at two inequalities at the same time. And the first way we're going to look at this is if we want both inequalities to be true at the same time. So the way this works is we can have an inequality like x is greater than or equal to -2. And if we take a look at the graph, that would be a solid dot at -2 with an arrow pointing off to the right. We could also have an inequality x is less than 4, and that would be a open dot at 4 with a graph pointing off to the left. So let's say we have these two inequalities, and we want them to be true at the same time. So what we're looking for is an inequality, and we can write it two different ways. We can write it simply x is greater than or equal to -2 and x is less than 4. Or we can write it as -2 is less than or equal to x, which is less than 4. And basically all that we did on this one was we took the x is greater than or equal to -2, we flipped the order of it, and we just put it backwards in here so then the x's line up. So that's the two ways we can write these inequalities. What this means graphically and in describing the solutions is that we take a look at I'm going to kind of extend some of these things out a little bit here because it's all the x's, they go on forever, right? And for the other inequality, it's all the x's that are less than. It just goes on forever, right? And the whole idea is the arrows are pointing in the directions of the solutions. So what I do is I take a look at one of the endpoints, like at -2 here, and I draw a line straight down and think about it going all the way down, and it cuts off that other line, right? It cuts off the pink line at -2. And so I'm going to put a solid dot at -2. And then I do the same thing for the other point. It cuts off the green line at +4 with an open dot. And if you take a look there, if you look right in the middle, that's where the two graphs overlap. We call this the intersection. The intersection, right? And what we do is we connect these two points together here. And the idea is where that intersection happens is the solutions to this compound inequality. And where they don't intersect, no solutions, no solutions. So the way this works, now I'm going to pick a point value. Let's just take -5 here. Let's see if -5 fits and makes this a true statement. -2 is less than or equal to -5, which is less than 4. Well, I take a look at both of the inequalities and see if this makes sense. So for a second, imagine you don't have this inequality here. Is -5 less than 4? Yeah, it is. That's true. Oop, that's fine. So that's true right there. Now, oh come on, let me highlight that thing back. Turn that back to black. Now let's just consider the first half of this. And this is kind of a weird way of looking at it here, but move that out of the way. Is -2 less than or equal to -5? And in this case, that is not true. And if you take a look over here, -5 It's true for the x minus 4 part of the, or x is less than 4 part of the graph, but not true for the x is greater than negative 2 graph. So the idea is it fits for one of them, but not both of them. And if you remember, for and inequalities, or these intersections, we want both inequalities to be true. Both of them are true. Now, most of the time you don't have to do this kind of crazy graphing right here. This is just trying to build the idea of where this compound inequality comes from. Most of the time what you do is you are given a compound inequality. This one here, it even tells us that it is an intersection. So that's good. Now we know it looks like an and. And I know my graph is going to look something like a barbell. Either it's going to be closed in dots or open dots, but that's what it's going to end up looking like. All I have to do, oh sorry, I forgot my 2 there. I just put negative down, is try to solve this inequality like normal. But the interesting thing that's happened here is there's basically 2 inequalities happening at the same time. So if I add 3 to make the x isolated and all by itself, I have to add 3 to the right side of the compound inequality and to the left side of the compound inequality. Oh, I forgot my negative there. All right. Negative 2 plus 3 is positive 1, which is less than or equal to x, which is less than 7. And that is going to be my compound inequality. I want all of the answers in between 1 and 7, and I want to include 7. So now I got to draw my number line. And this one, it's small enough I can actually like draw out most of the points, right? So let's go make that 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now one thing I like to do to really make sure it drives home that I know where the endpoints of this are is I'm going to put down 1 and 7 as their own tick marks. And now what I'm going to do to finish this graph, for the 1 it is less than or equal to. So on the left hand side where the 1 is, I'm going to draw a dot and fill it in because it's nor equal to. On the right hand side I have greater than, or sorry, a less than 7. So I'm going to put a dot at 7, but an open dot because it doesn't have an or equal to, and I want all the values in between. So that's how I would graph this inequality, this compound inequality. But solving it was just the same as doing the normal steps. You just have to watch out to make sure you're hitting all 3 of the spots, the left side, the right side, and the middle.